How do animals see? The answer is far more incredible than you might think. Eagles can spot a rabbit from 2 miles or 3.2 kilometers away. Cats see perfectly in near total darkness. The mantis shrimp has 16 types of color receptors, whereas we have only 3. But here's what makes animal vision truly remarkable. From the compound eyes of ancient trilobites to the basketball-sized eyes of giant squids, every eye design is perfectly matched to its environment, not through millions of years of trial and error, but through purposeful design. Today we're exploring how animals see the world and what their eyes reveal about the Creator. Welcome to Faith and Science. I'm Casey Verkerker. Joining me to discuss this topic is Dr. John Ashton. Welcome to the program, Dr. John.
Hi, Casey.
Dr. John has written a book called The Big Argument, Does God Exist? And in today's program, we're drawing on some more insights from this book. And we've been looking at Chapter 6 by Ariel Roth, which is about design in nature. So as I just mentioned, we see radically different eye designs across the animal kingdom. You know, we've got the compound eyes in insects, we've got camera eyes in octopus, we've got reflective eyes in cats. So if all eyes evolved from a single light-sensitive patch, why did evolution produce such vastly different solutions instead of perfecting one sort of design that went across all different creatures?
Sure. Well, the standard evolutionary response is that this is a result of natural selection. So you had whatever it was early on, some basic eye form, probably evolving from some light-sensitive spot that, developed and mutated into a more complex structure according to the evolutionary story. And then natural selection would eliminate the poorer design. So in the case of the eagle being able to high up in the sky spot the movement of some little animal down on the ground, then the eagles that had poor eyesight obviously died of starvation. And the ones that had the good eyesight bred and reproduced. So that's the standard model. But the issue that we face is, how do mutations produce this amazingly complex eye that is perfectly suited to focusing on long-distance objects like that? And also, it's not just the design of the eye itself, but the control mechanism of the eye, the muscles that are controlling the focus mechanism. They're controlled by nerves that are then connected to a brain. And then you've got the optic pathway, the chemicals involved to stimulate the brain to create the image and the brain to be able to interpret that. So you've got to have the development of the brain that matches the inputs from the eye as well. So you've got, extremely complex system there, and it's going to be different. The eye of your little grasshopper is going to be very different to the eye of the bird that is going to be chasing the grasshopper.
So we're talking about multiple completely different complex eye systems, aren't we, across all the different creatures, invertebrates, vertebrates.
Yes, and eye systems, the visual systems involve lots of different chemicals. In the different organisms, there are obviously different sizes. Now, different sizes require different construction material, different layers, for the physical size. Because of the physiology of the particular animal, they require different muscle structures to change focus, or different mechanisms for changing focus, this sort of thing, the chemistry, the biochemistry is amazingly complex. Coming from a chemistry perspective, which is my background, it's amazingly complex.
Right, that's interesting. And of course, with the evolutionary model, it looks back in history and tries to join puzzle pieces together with different organisms that we find, for instance, in the fossil record. And one of those is the Trilobites. But the trilobites, they appear in the fossil record with fully formed compound eyes. And there's no evidence of trilobites before them that have more simpler proto-eyes. So it's kind of like they just suddenly appear and then you've got, out of nowhere, complex eyes suddenly exist. How does this sudden appearance of sophisticated vision align with the idea of gradual evolutionary theory and a progression towards more complex design in these structures?
Yeah, well, that raises a very interesting question as to why we don't find the evolution of the eye laid out in the fossil record quite clearly for us. Trilobite eyes, of course, very different from our eyes. They're compound eyes made up of thousands of little tubes, of these calcite tubes that are pointing in all different directions, gave it amazing visibility, I guess, so it could see what was happening, any predators coming, this sort of thing. But the fascinating thing is, of course, that trilobites are right down in the bottom of the Cambrian layers largely. I mean, we do find them further up in the Cambrian as well, but the important thing is we find them right down at the bottom of the Cambrian. And they're quite an advanced organism with quite advanced eyes and also quite advanced body structures as well. You know, they've got segmented body, they've got quite an advanced reproductive system, like multiple legs, this sort of thing. Now, that requires, again, a huge amount of genetic code that is coordinated, and here they are right down the bottom of the fossil record. So, again, this is a major problem for evolution because where did evolution claims that over time you'll get sufficient mutations to produce these things. Okay, so below trilobites in the Precambrian, we have some very, very basic organisms there. There's quite a dispute over these organisms. And then suddenly we come to a layer just conformably above those layers where we've got trilobites, very advanced little creature. But the thing is that the whole creature itself just reeks of design and extremely complex genetic code. Now, one of the things is how could the code that complex have evolved over that time? And where's all the natural selection? Where are all the other, sort of intermediates before that? So the trilobite itself is a major, major problem for the evolutionary theory. And the just so stories that are made up in the textbooks to try and account for this, in my view, that's exactly what they are. They're stories of the gaps. They don't have an answer. And again, though, it points to a really superior and amazing designer that put together a code that resulted in this organism. So I can't say for sure, but I presume that trilobites came from an egg, some sort of single cell anyway that they came from, a fertilised egg. And so in that code, in that little egg, you had to have the code for all those parts.
Yeah.
And all the biochemistry, all the enzymes, all the, and again, not only the code, the ribosome to read the code. It's just so complex then, the code to, as I mentioned earlier, to account for all those body parts, let alone the eyes, which are quite advanced and obviously worked.
Yes.
And I know from fossils we have some very well-preserved fossils of trilobites, and some preserved fossils of trilobites have been quite large, so they've been able to really do some detailed studies of the structures of these eyes, and it's quite amazing the design structure of all these tubes, how they're arranged, the calcite, all this sort of thing, that had just the right refractive index to bend the light in just the right way that enabled the brain to interpret a focused image, so it produced a focused image that the brain could interpret and utilise. So their eyes are a real challenge for evolutionary design. Something that's that complex has to arise from quite complex code. How could that be so early in the evolutionary tree model? It's just a major problem. But again, to me, it's a no-brainer there's a creator. There was an amazing creator that created these creatures. They lived on the ocean floor. That's why we find them down the bottom of the fossil record. That fits. We know also that these fossils were preserved by major extinction events, global water extinction events that occur. There's 4 or 5 of them according to the record. The Bible account says there was one, and it wasn't that long ago. And we have, and evidence that we have for that it was recent, is that all these layers have been piled on top that have buried all these different creatures. They conformably sit on top of one another. There's no signs of erosion, bioturbulence, this sort of thing in between. So the timescales also fit that we've got a totally different worldview model that we need to look at to explain our origins. And that's why, Dr. Ariel Roth, who wrote this chapter, very big on design, as I mentioned briefly earlier in another episode, he was, for a long time, the editor of the journal Origins. He had access to a lot of the research that was going on. His conclusion was there must have been a supernatural designer.
Yeah, well, certainly with all of these details that we are discussing with the eyes, it seems like it is a more reasonable conclusion to come to when we see these gaps in things like the fossil record and so. How the genes could come up with some of these changes that we see. And of course, then there's the fact that, all of these creatures we're talking about, their vision is very much calibrated to their individual needs. The eagles, they need the distance ability. Cats, they need to be able to see in the dark. The mantis needs to see different colors. And with all of this fine-tuned optimization, is it possible for random mutations to even achieve that? I guess that's my question.
Well, again, I think that random mutations, and we need to look at this, are generally harmful.
Okay.
And that's another thing that glibly comes off the evolution. Mutations.
They tend to forget that detail.
Hang on. The majority of mutations are harmful.
Yeah.
They lead to changes that hinder the organisms. And Roth points that out quite early in his book too, that this is a very important point to look at. Most mutations are going to be harmful. Most mutations aren't going to work. For the odd mutation that may, in conjunction with a whole lot of other mutations, produce an advantage, you've also got to have all these other mutations pretty well occur at the same time, or it's just going to be another harmless one. So in other words, you can have a potentially positive mutation occurring, but unless it occurs in the environment of all these other ones, it's not going to work either. And so it's going to be classed as a useless and probably a hindering. And so this is a major bottleneck for evolutionary theory to claim that mutations can produce new organisms. And high-level researchers recognise this. Mutations don't produce new information. And a mutation produces a small mutations. Most of them, again, cause disease. And this is why top-level evolutionary biologists are really struggling to explain a mechanism for evolution. But they won't admit that. They've got to keep their grants going. They've got to keep writing papers. They've got to keep making new suggestions such as, maybe a whole lot of mutations occur all at once very rapidly, this sort of thing. But the problem is they can come up with all these stories, but there's no evidence for them in the fossil record. And the Trilobites are classic examples of that.
Yeah, very important to keep that in mind, isn't it? Because you can hear these things, as you say, sometimes they just can slip off the tongue. It was random mutations. But wait a minute, that produces negative stuff. So, really have to take all of these things into the perspective to get a more accurate conclusion. Thank you so much for sharing. Have you ever struggled with doubts about God's existence or known someone who has? What helped you through it? Share your thoughts and stories in the comments. Your journey could inspire someone else who's searching for answers.